Alright, so good morning. My name is Isaac. I would like to take you through a very short tutorial, and we want to introduce ourselves to mole concept. The concept of mole. Alright, so you must have heard some things about mole. You are probably watching this video because you sat in a class and then you did not really understand. But then we know a few things about mole. First thing, we may know that mole is just a number. And so, just as we have a dozen referring to 12, so a dozen referring to 12 pieces, so a mole would refer to some number of pieces. And that number is so huge that we might not be able to mention it. We write it in scientific notation. And the number is 6.02 times 10 to the power 23. So when I say that a packet contains a dozen, it means that the packet contains 12 pieces. Same way, when I say that a packet contains a mole, it means that the packet contains 6.02 times 10 to the power 23 number of particles, right? So because we are narrowing our discussion to science and chemistry, I would want to write particles here. So a mole contains 6.02 times 10 to the power 23 particles. Make sense? Yes. So every one mole, that is a number of particles in there. Let's take a look at a question. Okay. So this question says, how many particles are in 6.5 moles of an element? 6.5 moles of, let's say, chlorine. How many particles are in 6.5 moles of chlorine? Would you be able to answer that? Because we said every one mole contains that number of particles. So every one mole contains 6.02 times 10 to the power 23 particles. So how many particles will be in 6.5 moles? You are right. So then to find out, it will be 6.5 times 6.02 times 10 to the power 23. Alright. Okay, so let's punch that on our calculators and let's see how that gets us. So this is 6.5 times 10. 6.5 times 6.02 times 10 to the power 23. And that gives us 3.91 times 10 to the power 24 particles. Does this make sense to you? Right. Let's take a look at another example. How many moles are there in 9.14 times 10 9.14 times 10 to the power 24 particles. Would you like to, you can give this video a pause and try that out, and then we will later discuss. So how many moles are there in 9.14 times 10 to the 24 particles? You can pause the video and try solving the answer. How many moles are there in 9.14 times 10 to the power 24 particles? Well, let's see. So, I think that if every 1 mole contains 6.02 times 10 to the power 23 particles, then in order for us to find the number of moles that are there, we would have to divide 3.91 times 10 to the power 24 particles by 6.02 times 10 to the power 23. And what does that give us? You can check on your calculators. So I have 3.91 times 10 to the power 24. 3.91 times 10 to the power 24, all on 6.02 times 10 to the power 23. And that is 6.5 moles. 6.5 moles. Great. So that is the thing about mole. If you are thinking about mole, think mole as a number. Like I said, a dozen, it's a number. It represents 12 pieces of items. Just as you hear century, you think about 100 years. You hear decade, you think about 10 years. So when you hear mole, you think of the number 6.02 times 10 to the power 23. It's just a number. Well, how does this concept help us in chemistry learning? We know that chemistry deals with lots of minute particles, very tiny particles, and that it will be difficult for us to take the measurements of the mass of just one single tiny particle. And so the masses of the mass of a single tiny particle, the masses of elements are done, the masses of particles are done in moles, such that we do not, or we may not, discuss the mass of just one particle, but we would rather like to discuss their masses in moles. So I may not want to know the mass of just one atom of carbon, but I may want to know the mass of 1 mole of carbon, because one tiny speck, one tiny atom, even an invisible atom of carbon, is almost impossible to find its mass, except when it's done in moles. And so that's what makes mole, or the concept of mole, very important in chemistry. So you may have heard some things like molar mass, or molecular mass, or atomic mass, or whatever it is you may call it. But let's talk about molar mass. molar mass means the mass of a mole. So molar mass is just the mass of one mole. It is not the mass of a molecule per se, as some of you students like to call it. Molar mass is not necessarily molecular mass. Molar mass simply means that the mass of one mole of a substance. So the molar mass of of sodium, the molar mass of water, the molar mass of carbon dioxide. So the molar mass of sodium wants to tell the mass of one mole of sodium. The molar mass of carbon dioxide also wants to tell the mass of one mole of carbon dioxide. The molar mass of water wants to talk about the molar mass of one mole of water. Molar mass, that is just what it means. And so when you see a unit written as gram per mole, when you see a unit written as gram per mole, what is it trying to imply? It simply means the mass of one mole. Gram per mole means the mass of one mole. So when I make a statement and I say the molar mass of carbon is 12 grams per mole. What do I want to say? The molar mass of carbon is 12 grams per mole. What do I want to say? I simply want to say that every 1 mole of carbon weighs a mass of 12 grams. The molar mass of carbon is 12 grams per mole. The simple language I want to communicate is a language that every 1 mole of carbon is 12 grams or weighs 12 grams. Make sense? So when I say that the molar mass of magnesium is 24 grams per mole, what do I want to communicate? I want to say that for every 1 mole of magnesium, it has a mass of 24 grams. The molar mass of chlorine is 35.5. The molar mass, yes, of chlorine is 35.5 grams per mole. I'm trying to say that for every 1 mole of chlorine, the mass is 35.5 grams. Is this making sense? So we can follow something up here. You could see that if you are listening to what I'm saying very carefully, you could see that I am trying to draw a relationship between 3 friends. I talked about molar mass, and I know by now we know that molar mass is the mass of 1 mole of a substance. We can also talk about the mass, because the molar mass will be the mass of 1 mole. So I'm talking about mass, and I'm also talking about mole. So 3 friends have been discovered here: molar mass, mass, and then mole. Mind you, molar mass is different from mass. The mass of any substance is just what it weighs when it is put on a top hand balance. But the molar mass of the substance is the mass of 1 mole of the substance. So, when I put 1 mole of any substance on a top hand balance, it will give me its molar mass, because that will be the mass of 1 mole of it. But then, if I don't put 1 mole of it on a top hand balance, and I put the whole thing, or whatever lump I get on a top hand balance, the measurement that will read will not be its molar mass per se, that will be its mass. So this tells us that there is a relationship between molar mass, and then mole. Does this make sense? Before I go ahead and establish the relationship between molar mass, and mole, I want you to wrap your head around this problem. Let's see if you have any solution for me. How many moles of carbon are there in 18 grams of the element? How many moles of carbon are there in 18 grams of the element? We want to take the mass of carbon to be 12. The molar mass of carbon to be 12. I do not want to digress. I would have also talked about how we find the molar mass of an atom. But like I said, I do not want to digress. You may want to find another video that I've made about atomic mass, or the nucleon number, or the mass number of an element, because you'll see that the molar mass of an atom, which is called its atomic mass, is the same as its nucleon number with a unit. But there are earlier videos you can go check. Let's just assume, or let's just say that the atomic mass of carbon is 12. So, the molar mass of carbon is 12. So, let's try and answer this question. How many moles of carbon are there in 18 grams of the element? How do you think we'll solve it? Pause the video and try to wrap your head around this question, and then we will discuss it when you are done. Okay, so I want to find the number of moles of carbon that are there in 18 grams of the same carbon element. So let's say I walk to the lab, I took a scoop of, let's say, carbon powder in a container somewhere, and then I put it on my top hand balance. When I put it on my top hand balance, the reading I had was 18 grams, meaning that the mass of the scoop of carbon that I placed on my top hand balance is 18 grams. So I want to know that. So how many moles are there in this 18 grams of carbon? Because already I know that every 12 grams contains 1 mole. Every 12 grams contain 1 mole of carbon. So if I've had 18 grams of carbon on my top hand balance, how many moles will be in there? What do you think? Would it be something we'll divide, or something about multiplication? I am thinking that in order to solve this problem, we will have to divide 18 grams, which is the mass, by 12 gram per mole. Why do I need to do this? Because there is 18 gram of substance on the top pan balance. But I know that every 12 grams will give me 1 mole. So if I want to find how many moles are in that mass, I would have to divide by the mass of 1 mole, which is its molar mass. So let's do our division. So we see that gram will just go ahead and cancel gram. Grams cancel grams in this case. Mole has nothing to cancel. And 18 divided by 12, well, I do not want to waste time because I can do that on my calculator. So 18 divided by 12 gives me 1.5. So my final answer will be 1.5 mole. Does this make sense? So 18 grams of carbon contains 1 mole of carbon and a half mole of carbon. Could we establish any relationship between molar mass and mole? Well, let's see this. So in establishing a relationship between molar mass and mole, we would want to write number of mole is equal to, because in these calculations we did, where we did some divisions, we divided the mass by the molecular mass to find we divided the mass by the molar mass to find the number of mole. So the number of mole is equal to what? The mass divided by the molar mass. Alright, so this is what we have established so far. And I know many textbooks would have this formula. But I just explained to you why we have this. Number of moles is equal to mass over molar mass. Alright, I'll see you in the next video. Bye.